So on this worksheet, on these notes, you should graph the parent graph. So I've plotted all the points right there with the XY table. Obviously, you didn't have to use the XY table because you could use the pattern, the 1, 1, 2, 4, 3, 9. Let me box that in. We should all have that memorized, 1, 1, 2, 4, 3, 9. And we should all memorize that, 1, 1, 2, 4, 3, 9. Anyhow, let's practice graphing this guy with the pattern. What's the first step on graphing? Find the vertex, all right? Vertex. The vertex is a coordinate. You find that coordinate using the formula x equals negative b over 2 times a. Use it with parentheses, negative b over 2 times a, but we put parentheses there. And of course, we're going to label our values. The a value is negative 1, the b value is 2, the c value is negative 1. So we're going to plug in 2 right in there, and we're going to plug in the a value of negative 1 right in there. We end up with x equaling negative 2 over negative 2, which means that it equals positive 1. So our vertex x value is positive 1. So once you know the vertex x value and you need the y value, all you have to do is plug in the x value into the x's of your equation. And the smart thing to do is to rewrite your equation with parentheses and the location of where you're going to be plugging it in place of the x's. So I recommend you rewrite the equation with parentheses and then plug in that value right in there. And then you work it out. So 1 squared is 1 with the negative in the front. That will be negative 1. And then we have plus 2 times 1. That'll just be plus 2. And at the very end, we have a minus 1. Let's just bring that down. So we really have negative 1 plus 2 minus 1. What's your answer going to be right there? 0. So our vertex y value is 0. So let's go to the coordinate 1, 0 and put a dot right there. That is our vertex. Immediately after the vertex, we should all draw the axis of symmetry right through it. And of course, we need more coordinates. You could use the XY table. Because our a value is negative 1, we could continue graphing this with the pattern 1, 1, 2, 4, 3, 9. Now, if you had a different a value, you could modify the outputs on that pattern. But this is just a pattern. These are not coordinates. Don't go to the coordinate 1, 1. That would be incorrect. This is just a pattern from the vertex. But before applying that pattern, you need to know whether it's opening up or down, and you could clearly look at the a value and see that it's negative 1, which means it's opening down. So instead of going 1 over 1 up, we're going to go 1 over 1 down. Thank you, Ismail. So 1 over 1 down, and we'll put a dot right here. Then you go back to the vertex to do the next pattern, 2 over 4 down. 1, 2 over 1, 2, 3, 4 down right there. And of course, if we go back to the vertex and go 3 over 9 down, 3 over a 9 down would be way off the graph, so I'm not going to do that. Map them over to the other side, right here and there, and we have an awesome graph of this parabola. Just put some arrows on it because it does continue that way forever. We also need to be able to state the domain and range. What's the domain? X equals all real numbers. And the range, y is what? It's either above or below a certain value. It's less than or equal to. So here's a y value of 1. Does it actually exist up here? 2. Here, does it exist at the y value of 2? No, it doesn't even touch, right? It goes up, it reaches a max height, then it comes back down. What's that max height? 0. So y is less than or equal to 0. We should have all of this down. This is just a review from last week. So as you can see, the pattern saves you a lot of time. Okay, we're going to move on to today's actual lesson, which is transformations, all right? That's why there's a transformer symbol right there. Transformations. And we also have, what is that? Some parents with the child. Yeah, because we're going to be talking about parent graphs and transforming parent graphs, all right? So what the heck is a transformation? What does a transformer do in the movies? Transforms from a car to a robot, right? From a robot to a car. So right here we're going to be transformed. We're going to be changing this, the location of these different parabolas and changing the shape of these different parabolas. Before moving on to different types of transformations, let's talk about different forms of quadratic equations that also graph parabolas. So far we've only been working with standard form, and remember f of x, that's just the same thing as y. So you could put a y right here if you wanted to instead of the f of x. But we've been dealing with, and that's why I have it down here, y equals. So I guess you could leave it f of x. But anyway, f of x is the same thing as y. And we've already been dealing with these standard form quadratic trinomials, ax squared plus bx plus c. The a value is the number in front of the x squared. The b value is the number in front of the x. So that's what the details say down here. A, b, and c are just numbers. Now, on standard form quadratic trinomial equations, we find the vertex. Remember, the vertex is a coordinate, and the x value of that coordinate is found with that vertex formula, x equals negative b over 2a. And to find the y, you simply plug this back in to find the y. The axis of symmetry is that exact x value of the vertex. Actually, we forgot to state that on this one. What's the axis of symmetry on this one?
1.
Yeah, but give it to me as an equation. X equals 1, that's right. X equals 1 is the axis of symmetry, the vertical line crossing through that vertex x value of 1. Okay, so let's go back over here. We also know that the a value tells you if it opens up or if it opens down. If the a value is positive, that's what it means by greater than 0. If the a value is positive, it opens up. If the a value is negative, if it's less than 0, then it opens down. Okay. We could also use a table of values to find other coordinates and use the axis of symmetry to map points to the other side. And we could use the pattern 1, 1, 2, 4, 3, 9 on any parabola that has an a value of 1. We also have even discussed that the further your a value is from 0, the more vertically stretched it gets. So I might as well just jot this down quickly right here. So let's say your a value is 2, then it gets vertically stretched. It gets narrower, right? The a value of 3, that gets even narrower, right? So if it gets closer to 0, like if I go a value of 1/2, then it gets wider, okay? If you go a value of 1/10, then it gets super wide, okay? So the a value not only tells you if it opens up or down, but it tells you if it's wide or narrow. The further it is away from 0, the narrower it gets, the more vertically stretched it gets. And we'll get to that in a couple minutes. We'll review that some more. But let's talk about today's new form, vertex form. Vertex form. Now remember, form is just the way it's organized, the way it looks. So vertex form is y equals a parentheses x minus h squared plus k. Ladies and gentlemen, we have to memorize this. Kind of like standard form, we knew that standard form was ax squared plus bx plus c. Vertex form is a parenthesis x minus h squared plus k. Let's talk about the details. A, h, and k are just numbers. Kind of like a, b, and c on standard form. A, b, c, those are just numbers. Over here, the a, the h, and the k are just numbers. That's just a number, that's just a number, that's just a number. Now, the a value here is the same exact a value over here. Now, what do I mean by that? It tells you the same exact thing. If this guy's positive, it's going to open up the parabola. If the a value is negative, it's going to open down, right? The further away the a value is from 0, the more vertically stretched it gets. The closer it is to 0, the more vertically compressed it gets. What does that mean? If you had an a value of 5, it's a narrow graph. If you had an a value of 1/5, then it would be a wide graph, a wide parabola, right? So the same thing with the a value on standard form is right here on vertex form. The a is exactly the same, tells you the same exact things. By the way, let's say you did have the a value of 1 on a vertex form equation. Then, just like the other one, you could use the pattern 1, 1, 2, 4, 3, 9. Okay, now here's the important part. Vertex. The vertex, there is no formula. The vertex is h and k, and that's it. So whenever you see an equation that's in vertex form, you could clearly take this value and that'll be your vertex without doing any math. On this guy over here, to find the vertex, you had to do negative b over 2 times a. You had to simplify correctly and get the x value, and then you had to plug in that x value into the original and solve for y. That's a lot of work. Right here, instantly, if it's in vertex form, the h and the k value are your vertex. The vertex is hk. I guess that's why they call this vertex form, because if it's in this form, you could just see the vertex without doing any math. You could identify the vertex without doing any math. But look at the tip down here. The vertex is h and k, but the tip says, when you look at h, think opposite value. So the reason why that is the vertex form has a minus, and minus means opposite. So whatever you see in here with the x, you have to think opposite, okay? Maybe I should give you an example. Let's come up with an example here. So here we have a vertex form equation. It's y equals negative parenthesis x minus 2 squared plus 1. Now this is in vertex form. What is our h value and what is our k value? Now remember, the tip says when you look at h, think opposite of what you see. So what do you guys think the h is? What's the h? You got to think opposite of what you see, which will make it a positive 2. Make sense? Now the k value, you just take it for what it is. So what is the k value? 1. So what does this mean if you identified h and k? That means that your vertex is simply the coordinate 2, 1. You don't have to do any math. If it's in vertex form, you could identify your vertex. Now, let's even take this further. Let's take this and let's actually graph it. So let's go to the coordinate 2, 1 and put a dot right there. The next step would be to draw our axis of symmetry right through it. And then you need to get more coordinates. Now, let me ask you this, guys. Is this original equation opening up or down according to the a value? What is your a value here? What's your a value? It's negative 1. Okay, if it were 0, think about this. If it were 0, 0 times anything is 0, right? So it can't be 0. It has to be a negative 1 right here. So because the a value is actually negative 1, now remember, here's your h and here's your k. Because the a value is negative 1, we know it's going to open down, and we know we could use the pattern 1, 1, 2, 4, 3, 9. So just by looking at it, you have your vertex 2, 1, and then by knowing that your a value is negative 1, you could go 1 over 1 down and put a dot right there. And then you could go back to the vertex and go 2 over 4 down, 1, 2, 3, 4, and put a dot right there. And you could obviously map them over to the other side. So it's 1 unit away, it would be right there. Put a dot right there. And the other one's 2 units away, so that would be right here. Graph your parabola. And that's a perfect, if it were on graph paper, it would be perfect. But that's a perfect description or a perfect graph of this parabola that's in vertex form. How much math did we do? Nothing. We just identified h and k. You got to think opposite on h. On whatever you see, think opposite. And the k value, take it for what it is. You'll have your vertex, draw your axis of symmetry. You need some more points. Look at your a value. If it's 1, use the pattern 1, 1, 2, 4, 3, 9. If it's positive, it's opening up. If it's negative, it's opening down. And it's that easy, guys. So this vertex form, don't think of it as something new, that even though it is something new that we're learning, think of it as something like a shortcut, something better. We're going to be able to graph even faster if it's in vertex form. So let's flip this paper over. Before jumping into graphing, let's talk transformations, okay? So there's different types of transformations. There's reflections, right? And we've already been talking about reflecting coordinates from one side of the axis of symmetry to the other. But a transformation that reflects or flips a graph or figures across a line, here's where it happens. If the a value is negative, then we know it's opening down. That means that the original parent graph that was opening up got reflected over the x-axis. So a negative a value will reflect it over the x-axis. And this is why, if the a value is negative, the parabola opens down. A vertical compression what is a vertical compression? The A value tells you if it gets vertically compressed or stretched. If the A value is less than 1, it gets vertically compressed. Okay, so here is let's say y equals x squared. That produces a regular U-shaped curve. Okay, but if you take that A value of 1, right, there's a 1 right there in the front. If you switch it to like a 1/2, y equals 1/2 x squared, then your parabola gets wider. What happened there is that it got vertically compressed by the value of 1/2. That's what we say when we describe it. It got vertically compressed by the value of 1/2. Now, if the A value is greater than 1, then it gets vertically stretched, which means pulled away from the x-axis. The parabola gets narrower. So if I did have y equals 5x squared, then it wouldn't be a regular U-shaped curve. It would be a U-shaped curve that's like very, very narrow. Okay? But we should already know that from what we've been graphing with standard form. Let's move on to translations. So we already know that a vertical stretch, the parabola gets narrower. A vertical compression, it gets wider. A translation. What's a translation? It's a transformation that just shifts or slides every point of a figure of a graph the same distance in that same direction. Okay, so the parent graph is the simplest type of graph where the A value is 1 and the H and K are both 0. So we've already been graphing y equals x squared. That's a parent graph of any parabola. When you have the A value of 1, you could use a pattern 1, 1, 2, 4, 3, 9. Now, vertex form, the H and the K moves that vertex from 0, 0 to the new HK value. Okay? So technically, when you talk about your parent graph and changing it to this new graph, to this new graph of whatever it is, it's going to slide around according to H and K. So the translation is the H and K units. So, fact about this vertex form, H is always inside of the parentheses with X. Okay, H is always inside parentheses with X. Let me ask you this, what if there is no parentheses? Like what if I told you this, y equals x squared minus 3, and I told you what's your H value? What would you say the H value is if you know that your H is always inside parentheses with the X? H is always inside parentheses with the X. Is there parentheses? No. So if you wanted to imagine parentheses right there, go ahead. What's your H value in there with X? Is there an H value in there with X that you're adding or subtracting? No. So you could actually do this. You could put H or X minus 0. That would mean that the H value is 0, right? So your vertex X value is 0. What's your K value? What's your K value, guys? Negative 3. So the vertex, according to this example I gave you, that didn't even have parentheses, right? It was just y equals x squared minus 3. That vertex is 0, negative 3, just by looking at it. Now, of course, you could have treated this like a standard form quadratic equation or binomial and done negative b over 2 times a, and you'd have, there is no b value, that would be 0, and you'd get 0 for the x, and you get the c value for your y on the vertex. But if it's in, you could look at it in vertex form or standard form in this case. So you first have to check what type of equation they're giving you. Are they giving you a standard form equation, ax squared plus bx plus c? If they are, then you're going to have to use the vertex formula that we've been using, x equals negative b over 2 times a. Or if it's in vertex form, then you simply identify h and k, and that's your vertex. But either way, if your a value is 1, you're going to be able to use 1, 1, 2, 4, 3, 9, right? And even if your a value is not 1, you could modify the second values on these patterns to make it fit your needs, right? So let's take a look at this first graph. Graph the following parabolas. What do you guys say? Does it open up or down? Come on, people. Open up or down? Down. Down. Do you need to use the formula to find the vertex? Nope. No. Why not? Because it's in vertex form, right? And if it's in vertex form, you just identify h and k. So what is your h value and what is your k value? Positive 1, comma, positive 3. That's your vertex. Graph it. 1 on the x, 3 on the y. There it is. Axis of symmetry. Line right through it. You need more coordinates. You could either go to a table, plug in some numbers, pull out some answers, but that'd be pretty challenging. Like if you plugged in a 0, 0 minus 1 is negative 1, negative 1 squared plus 3, you get your y value. Instead of doing all that, because our a value is negative 1, it's opening down, and we can use the pattern 1, 1, 2, 4, 3, 9. So from here, 1 over, 1 down, put a dot there. And then go back to the origin and go 2 over, 4 down, put a dot there. And you could go back to the origin and go 3 over, 9 down. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 unit off. I guess I'll plot it even though it's 1 unit off. Map it over to the other side. And you could draw your parabola. So notice that I did just put arrows pointing at those other points off the parabola. And that's it. It's really easy to graph. It's in vertex, if it's in vertex form. Now right here, you do have the option of treating this like a standard form quadratic trinomial or quadratic binomial where your b value is 0. And you could go back and use the formula x equals negative b over 2 times a. Or you could also treat this like a vertex form equation. All right? I would treat it like a vertex form equation. Y equals parenthesis x squared minus 5. Now notice there is no parenthesis here. That means that there is no h value. So if there is no h value, you're going to represent that by saying minus 0. Okay? So the original could be rewritten like, whoa. The original could be rewritten like this, where your h is 0 and your k is negative 5. And ladies and gentlemen, that tells you your vertex. Vertex is h and k, where your h value is 0, your k value is minus 5. Remember, if you did have an h value, you have to think opposite of what you see. But right there, 0, it doesn't matter if it's positive or negative. So let's go to the coordinate 0, negative 5. Does this open up or down? Up. It opens up, that's right. And could we use the pattern 1, 1, 2, 4, 3, 9? Yes. Yes, we can. So from the vertex 1 over 1 up, and then go back to the vertex 2 over 4 up, go back to the vertex 3 over 9 up. And then reflect them to the other side of the axis of symmetry. So this one's 3 units away, go 3 units away this way, put a dot right there, and the next one, and the next one. Draw your line right through those points. Whoa, kind of went crooked. And as you can see, it's a lot easier to graph when you have vertex form. Now again, you could have considered this standard form and said, oh, my b value is 0. Let me find the vertex, x equals negative b over 2 times a, negative 0 over 2 times 1. And you would have found out that your x value is 0 on your vertex, and then you'd plug in 0 to find out that your y value of your vertex is negative 5. But that's a lot more work than necessary. If you think of it in vertex form, you could clearly see that your vertex is 0, 5. This guy, what is our vertex? Negative 3 and negative 5. Let's go to negative 3 and negative 5. Negative 1, 2, 3, negative 1, 2, 3, 4, 5 right here. Let's draw our axis of symmetry right through there. Now we need some more points. Could I use the pattern? 1, 1, 2, 4, 3, 9. Does this open up or down? Up. So 1 over from the vertex. I'm going to the right 1, up 1. There it is. Going back to the vertex, to the right 2, up 4. And I'll be up here. No, is that right? No, that's wrong. Wait up. Right here. And then I'll go back to the vertex and go 1, 2, 3 over and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. And of course, we're going to map them over to the other side. Draw our parabola right through those values. Put some arrows on it. We're good. Now, let's compare this guy to the original parent graph y equals x squared. Right? The original parent graph y equals x squared has a vertex at 0, 0, and it has that pattern of 1, 1, 2, 4, 3, 9. So you'd have that perfect U-shaped curve right through the origin 0, 0, or with a vertex at the origin 0, 0. This new parabola is the same exact width. It's not vertically stretched or compressed. It just gets translated from the origin 3 to the left and 5 down. 3 to the left and 5 down. So that's the translation or the description of the transformation from y equals x squared to this new parabola. So what do you guys say? Do you want to use standard form on this guy or vertex form? Pick one. Vertex is the easiest. Now you might want to rewrite this, right, with parentheses just to make it more understandable. You could rewrite it as y equals negative parenthesis x squared minus 1. Now, why did I do this parenthesis with the space right there? Because there is no h value. So what am I going to put for h? 0. So I'm going to put minus 0. Okay. And then I could clearly see that my vertex is what? What's my vertex? 0, comma, negative 1. Okay. So let's go to the coordinate 0, negative 1. Let's draw an axis of symmetry right through it. Let's use the pattern 1, 1, 2, 4, 3, 9. But am I going up or am I going down? Down. My a value is negative. So 1 over 1 down. 2 over 1, 2, 3, 4 down. I'm already on the edge. Just map them over to the other side. And we have our parabola. So vertex form is awesome. Helps you graph in a couple of moments as opposed to minutes. This guy over here, how about this? What's the vertex on this one? Well, it's in vertex form. Everybody should be able to tell me what the vertex is. What's a vertex? Negative 1, comma, 0. That's right. There is no k value. And notice that we did think opposite of what we saw here. That's how we get our h value of negative 1. The k value is the number that's being added or subtracted all at the end. There is no number being added or subtracted, so the k value is 0. Let's graph negative 1, 0. This is my vertex. Let's draw the axis of symmetry right through it. We need more points. I could use a pattern. What's my pattern? 1, 1, 2, 4, 3, 9. Is it going up or down? Down. So 1 over 1 down. Go back to the origin. 2 to the right and 4 down. 1, 2, 3, 4. If I went 3, 9, I'd be off the graph. So let's just map them over to the other side. And this one to the other side. Let's graph our parabola. And we are good. Now let's not forget about those other questions I could ask you, like the domain is x equals all real numbers, and the range, this whole parabola is at or below 0, so y is less than or equal to 0. And that's about it for this two-sided page of notes.